Hello, Sam from Tool Hut here today. Today's victim, 2008 Chevy Silverado 4-door, long box, 2500 HD with a diesel in it. Transmission complaint. Hey, wait a minute. That's my truck. Yes, it's true. This is my truck. So anybody sees me driving around the Detroit area will know that this is my truck. Actually, my son was driving this truck when it broke. I've kind of harassed him about screwing with it, but I'm sure he didn't. I knew he didn't before we figured out what was wrong with it. So Tool Hut has all of your tool and equipment needs for diagnostics, drivability, etc., etc. We offer training and support on all of our equipment. My name is Sam. I'm a mobile diagnostics guy for Tool Hut in the state of Michigan. So this is the scenario. This is not one of the vehicles that we drive on a daily basis. This is kind of a backup vehicle we use. Obviously, it's used for towing a trailer that we've got, because that's what it's built to do. And as far away from the house as my son could get, he calls and says that the transmission, there's a message on the dash that says, when he puts it in drive, it says shift inhibited, shift to N, or move to N, or something like that. So I'm going to kind of take you through the process. I will be honest with you, I didn't plan on making a video of this, so I don't have a lot of pictures. But trust me, I'm going to show you our thought process, and then I do have a picture of the problem that we find, which is the reason I decided to make the video. Because this is no previous complaints. We have had this code kind of intermittently pop up. It has never caused the check engine light. Just when you do a code scan, you'll see it in there periodically. But absolutely no problem, no complaints, nothing. So about 170,000 miles on the clock or so. So it's not new. We've owned it since about 100,000 miles. So stay tuned as I talk you through the process here. So we're going to handle this just like any other diagnosis. So the first thing I like to do is I like to pull up, once I got the code, pull up the description of the code. And I kind of like to go through their step-by-step process. I rarely follow it, but I kind of like to scroll through what the engineers think you need to check for this code. Sometimes it's kind of revealing of what they're thinking, how they came up with this code, stuff like that. I also like to look at the symptoms and the criteria for the set in the code. So this is where I'm starting. I've opened up my service information. I do use MotoLogic, so I got MotoLogic open, and I'm just kind of going through my code setting criteria. I think it's kind of interesting that it says that the engine RPM has to be in excess of 250 RPMs, but less than 7,500 RPMs. So I know that the guy that built the engine did not consult with that information, because there's no way this 6.6 diesel will spin 7,500 RPMs. So I just kind of scrolled through this. Like I said, I rarely follow the step-by-step procedure anyway, but I do like to sometimes it helps you with your diagnosis. So the first thing I want to do is I'm going to pull up the wiring diagram for this shift solenoid circuit, because that's what I got, is shift solenoid 2 circuit code. So once I've got the diagram pulled up, it's going to give me my pin numbers at the TCM. I don't know, might say I'm lazy, whatever. I always look at the easy way out. So I'm going to disconnect this connector right at the transmission control module. This connector right here. And we're going to start doing our test right here. And if everything's good here, then we know that the PCM is bad. By the way, this transmission control module is bolted to the shroud, or clipped to the shroud, the radiator shroud, so it's super easy to get to. So, and I don't have to lay on the ground underneath the truck to do any testing. So that's where I started. Okay, so we got the transmission connector unplugged, and I got a connector view, a connector layout, if you will, of the transmission control module. Now, according to our wiring diagram, we need pins 71 and 33. Well, one of the things I like to do before I test the bad circuit is test a good circuit. So I am going to cross pins 71 and 52 with my ohm meter and measure the resistance of shift solenoid 1. Now, some might argue that the problem, I may have a problem with shift solenoid 1 as well. I'm going to check 1 and 3, and then I'm going to check 2. So I'll have, what's the chances of all 3 of them being bad? I guess there is a chance, but the service information said 22.5 ohms. Measuring it as I was looking through the sheet. And so I'm going to check pin 71, because that's our common. That's going to be our voltage in to the solenoid pack. And then the other side is going to be the ground side controlled side of the solenoid. So just measuring between the 2 pins should give me the resistance of just the solenoid and the circuit, obviously. But it's going to give me some direction. So the first thing I do, put that on there, and I have 22.5 ohms for shift solenoid 1. According to the code setting criteria, I know that there's nothing wrong with this circuit here. And before anybody says anything, this does have the typical harness leaking. We do have a harness ordered for it, and that's part of the reason I'm doing some testing here before we drop the pan. I want to know if the problem's in the pan or not. So my next step is I'm going to check shift solenoid 3, kind of the same way. I'm going to, like I said, pin 71 is our common. So the next thing we're going to do is we're going to go to pin 51, which is shift solenoid 3. And we're going to measure the resistance on shift solenoid 3. And the resistance on shift solenoid 3 is about 22.5 ohms, 22.6-ish. Again, to me, well within specifications of what it should be. And the next thing I do is I put my meter on pin 33, which is shift solenoid 2, and I have 64 ohms of resistance. So I know for a fact that there's a problem. So the next thing we're going to do is we're going to go down to the transmission. We're going to lay underneath the truck. Yeah, I know. That's what I was trying to avoid. And we're going to unplug the connector at the back of the transmission. And we're going to measure the resistance of the solenoid without the circuit involved. Now, I'm going to do the same thing. I'm going to measure all 3 shift solenoids. And I will tell you that the resistance is 22.5 ohms on all 3 shift solenoids. So, I know for a fact that my problem, even though I have a leaking harness, is not inside my transmission. Now, I'm obviously going to fix the problem inside the transmission, or the leaky harness as well. But I know I don't need to buy any solenoids. I'm not having a shifting well, I'm having a shifting problem right now, but it's due to the code. So, like I said, I know now what I need to do. So, the next thing I do is I put my meter lead extensions on, and I measured the resistance of the wire from the transmission control module to the connector underneath the truck. The transmission control module's unplugged, and again I'm going to measure all three circuits. Shift solenoid 1 and 3 is 0 circuits, or 0 ohms, and shift solenoid 2 circuit, the yellow wire with red stripe, is 42 ohms. So I know now for a fact that my test results are not deceiving me. I'm not a big fan of ohming wires, I will tell you that. But I felt the information that could be gathered from the resistance test of the wiring was beneficial at this point. So it did get me kind of in the right direction. The next thing I did, I know how much everybody loves this, I pierced the wire back behind the connector and measured the resistance without the connector at the transmission involved, because I do have a leaking transmission connector. So is that transmission fluid causing any kind of problem inside the connector? So I went back off the connector about 6 inches and measured the resistance of that wire again from the transmission control module to about 6 inches from the connector, and my resistance was exactly the same. So the next thing I like to do is I'd like to try to split the system in half. Let's figure out where our problem is and move on. Went over to the left side of the transmission. The harness goes up over top of the transmission. Obviously, I don't want to go into that if I don't need to. So I find an easy spot to pull the conduit back and measure the resistance. And interestingly enough, as soon as I pull the conduit back, I see a bulge in the wire. I don't see any sign of where it's been hurt, pierced, tampered with, nothing like that. The wire's just got a bulge in it. And ironically enough, it's the only wire down here that's got a bulge in it. So I grab it with both hands and I give it a good tug, and it breaks right apart. So here's a picture of the wire after I broke it. So now I know for a fact that where my problem is, and I do measure the resistance of the wire back to the transmission control module and over to the connector, a couple different ways here, just to verify that this is the one spot that I'm getting my 42 ohms of resistance, and it is in fact. So I stripped this wire back 3 or 4 inches, cut it back, and solder and shrink wrap in a new piece, and I measure the resistance at the transmission control module again down to everything's plugged back in, so I'm measuring the resistance of all of my solenoids, and I got 22.5 on shift solenoid 1, 22.6 or so on shift solenoid 3, and on shift solenoid 2 I got 22.6 or 22.7 ohms, so well within the tolerant, I believe. So that's it. It's kind of the whole thing in a nutshell for you guys here. Questions, comments, hit the subscribe button, hit the bell if you want to be notified as I'm releasing more of these. Follow us on Facebook. It's Tool Hut USA. Visit our website, toolhutusa.com.